Today we want to talk about how to stretch graphs. So what I'm going to do is I'm going to look at a basic graph that I'm familiar with, y equals absolute value x. And just a simple table of values for that. And so we know the graph looks something as shown. So now what I'm going to do is I'm going to take x and I'm going to replace it with 2 multiplied by x. And so I've made a change to my x, and the way I'm going to think about this is how do my x values in my table change to produce the same y values that they did before. So if I take the point 0, 0, we know that 2 times 0 is 0, and that'll output 0. I'm going to take 1, 1, and so I know that to get 1 out, what I have to put in, before I was able to put in 1, but now since my x is being multiplied, my input's being multiplied by 2, my original x value is going to be half of what it was before to compensate for the multiplying of 2. So my new point is 1/2, 2. Okay, one more time on this next point. So a 2 in produces a 2 out, but if my input's being multiplied by 2 already, then my new input is going to have to be half of what it was before, or in this case, 1. And so what you can see is that all of my x values have to be half of what they were originally in order to compensate for the multiplying by 2 in my equation. So when I graph the transformed relation, the effect of all of the x coordinates being halved is going to mean that my graph is pushed in towards the y-axis by a factor of 1/2, and that's what we call a stretch. You can kind of think of it as pushing on both sides of the graph horizontally so that all of the x values are halved, and depending on how far each point is away from the y-axis determines how far it moves. The new graph is a horizontal stretch that's with respect to the y-axis, so being pushed in or out from the y-axis of the original graph by a factor of 1/2. In terms of the effect on the points, my original xy's, to compensate for the multiplying by 2 of x in the equation, meant that I had to take x values which were half as big to produce the same y values as before. Okay, in our next situation we're going to take our basic absolute graph and we're going to replace x with 1/2 of x, or if you prefer x over 2, and look at the effect of the changes in x if we want to keep the same original y values. So when I input my value, my output comes out. If 0 is going to come out, 0 has to go in, and since my new input is being multiplied by 1/2, I can still use 0 because 0 times 1/2 will be 0, and inputting 0 will still produce an output of 0. Okay, let's change this. So now we want to have 1 come out, and we know that the whole thing in here has to be 1, but since my input is going to be divided by 2, it means that my new input has to be twice as big as it was before. 2 divided by 2 to give me 1, and the absolute value of 1 to be 1. And so what you can see is happening is that all of the values of x now have to be twice as big as before to compensate for the fact that I'm dividing by 2 in my equation. So when I graph these points, the effect of all of the x values doubling is going to mean that the graph pushes out from the y-axis by a factor of 2. It stretches by a factor of 2. So our new graph is a horizontal stretch from the y-axis by a factor of 2. And in terms of my coordinates, my original points x, y, the x had to double to compensate for the dividing by 2 or the multiplying by 1/2 in the equation. So to generalize this result, when x is replaced by b times x, y equals f of b times x will be a horizontal stretch about the y-axis. So the pushing or the pulling in is happening from the y-axis to the x-coordinates. Will be a horizontal stretch about the y-axis by a factor of, I'm going to write 1 over absolute value b, just because if b was negative, that would be a reflection across the y-axis, compared with our original graph. So if changing x to a value multiplied by x does a stretch horizontally, then you would expect that replacing y with a number multiplied by y would do a stretch vertically. In this case, I'm replacing y with 2y. And just in my equation here, I'm actually preferring to put the half on the other side, y equals a half x. So let's think about this in terms of no change is going to be made to my x's. And I want to think about the effect on my y's. So in terms of my understanding of this, I'm going to focus in on this. So I put my number in. So for example, if I put 0 in, I get 0 out. And the fact that my output is multiplied by 2, that will not affect anything because 2 times 0 will still be 0. So my new point, my original point 0, 0 is still 0, 0 under the transformation. Okay, let's erase this and take our next point, 1, 1. So 1's going in and 1's coming out. But what we're calling 1 is 2 times y. Since my y is multiplied by 2, the actual value that I'll use on my table will be half as much as before to compensate for the multiplying by 2. And so you can see what's going to happen here. All of the original y values are going to be divided by 2. So what has happened is you can imagine someone pushing down on the black graph by a factor of a half, which is what's causing each of the y values to multiply by a half, and you're therefore getting this stretch. So this graph, which is the same as this graph, is a vertical stretch with respect to the x-axis. So it's vertically pushing down or up or down from the x-axis is the way you want to think of that. This is a vertical stretch by a factor of a half compared with your original graph. Okay, finally, let's replace y with a half y, or if I want to isolate my y equals 2 absolute x, and see what the effect on the graph is. So I want to keep the original x values and see what happens to the y's under this change. Let's start with this point this time. 3 goes into the absolute value and out comes 3. But since I'm calling my output right here a half y, the actual value of y has to be twice the size it was before to compensate for the multiplying by a half. 6 over 2, or 6 times a half, is my output of 3. And so you can see that all of my y values are twice the size they were before to compensate for my multiplying by a half, or dividing by 2. If I graph these points, the effect of all the y values being doubled is going to push them up by a factor of 2 from the x-axis. And so to summarize, replacing y with a half of y means that my y values have been doubled. I'm going from points of xy to points of x, comma 2y. A half of y equals absolute x, which is the same thing as 2 absolute x. It's a vertical stretch from the x-axis, pushing up from the x-axis by a factor of 2. Notice that the factor here and here match, or in this case they are reciprocals of each other, inverses, dividing by 2 versus multiplying by 2, compared with your original graph. Okay, so to generalize this, I'm going to do my notation a little bit differently for vertical stretches. If I replace y with y over a, you might say, well, why don't I say a times y? I could, but I'm choosing to do it this way because in my equation, that's going to be my equation, this will be my equation, and since we like to isolate y, it's more conveniently written this way. So we know that what this is a vertical stretch by a factor of. Now you'll notice that if you isolate y, then the vertical stretch factor is this number. If you keep the number with the y, then it's the reciprocal of the value. So if you're dividing by a, the actual effect is multiplying by a. So however you want to look at that, just get your head around it. This is a vertical stretch by a factor of, and we say absolute value a because if a was negative, we'd have a reflection in the x-axis. And a vertical stretch we say is about the x-axis. The pushing or pulling towards comes from the x-axis. This is all true compared with our original graph. So let's put all of this together by graphing this transformation. And so what I'm going to do is I'm going to go step by step, one transformation at a time until I have my final graph. So I'm starting with y equals f of x, which is what's drawn in black. So let's do this, and we know that replacing x with negative x does a reflection of the graph in the y-axis. The next thing I'm going to do is I'm going to replace x with x over 3, and that's going to be, it's a division or multiplication, it's a multiplication of a third on the x, so that's a horizontal stretch of the graph by a factor of 3, multiplying by a third. The actual effect is tripling. So all of my x values on these points need to triple. X value of 3 becomes an x value of 9. So all of the points are being pushed out from the y-axis by a factor of 3. X equals 2, tripled, x equals 6. This is meant to be at 0, so that point will be the same. X value of negative 2 becomes an x value of negative 6. Sorry these lines aren't straight. It's very difficult to do this accurately on a symposium. And finally this x value negative 3 tripled will be negative 9. And our final transformation is to replace y with 2y. And if you want to bring the 2 to the other side, that's fine. Just be sure you understand how to interpret this. It's a change in the y, so that would be vertical because it's with the y, stretch because it's multiplied or divided. You can think of it as that. Vertical stretch by a factor of the reciprocal of 2, a half, or if you move it over, it's just this value, however you want to remember that. So all of my y values need to be halved, which means that it's going to pull them closer to the x-axis. So the graph goes like that. Y value of 2 is a y value of 1. Y value of 0 is a y value of 0 after it's halved. Y value of negative 2, half of that is negative 1. And a y value of 2 halved is positive 1. And there's my final graph in green.